Hey guys, today we're going to start graphing polynomials by looking at a couple key traits of the function. We're going to be looking at degree and multiplicity, as well as whether we have a positive or negative lead coefficient to determine things like in behavior and the multiplicity of the zeros to see if a line goes through the x-intercept or if it just touches the x-intercept, okay? We're going to start by looking at in behavior and just kind of doing a quick refresh, looking at some familiar functions, okay? The first one is just a line. If you look at the left, we can see that the in behavior is falling on the left. And then on the right, it is rising because it's going up to the top. Okay. You guys are familiar with that. Second one's x squared, where they're both going up. So that would be rising, rising. Okay, I'll let you guys go ahead and finish the rest. And then when we come back, I'm going to go ahead and pause it, finish it. I'm going to wait a few seconds. I'll go ahead and write in the answers, and you guys can check your work. Okay, so let's take a quick look at what we had here. When we had y equals x, just a linear, remember that our degree there is 1. When the lead coefficient was positive, and we had a positive x, it was falling on the left and rising on the right. When we flipped it, it was rising on the left and falling on the right. For quadratics, when we had an x squared, when it was positive, lead coefficient, it was rising, rising. When it was negative, it flipped it and was falling, falling. X cubed went back and acted like the linear with the end behavior. On the left, it was falling. On the right, it was rising. But then when we had the negative coefficient, again, it flipped and it became rising on the left, falling on the right. The quartic was rising, rising, just like the x squared was. And then when it was falling, or when it was negative coefficient, it was falling, falling, flipped again, okay? So the x squared and the x to the fourth were very similar, as were the x to the first, or that linear, and the x cubed. That's because coefficients and in behavior, positive or negative coefficient, and the in behavior has to do with the degree of the polynomial. When the leading coefficient is positive, and you have an even degree polynomial, x squared, x to the fourth, x to the sixth, you're always going to have rising, rising as our in behavior. Rising on the left, rising on the right. When it goes negative, that's going to flip. It's going to be falling, falling. When we have an odd degree polynomial, x to the first, x to the third, x to the 11th, any of those, you're going to be falling on the left when the lead coefficient is positive and rising on the right. And then when lead coefficient becomes negative, that flips. We have rising, falling. And once we're done with our in behavior, we move on to looking at multiplicity. Multiplicity is going to tell us how many times a factor repeats, or how many times each zero occurs. And to find that, we're simply going to look at the degree of each individual factor. So when we do that, if the multiplicity, or the degree of each factor, is even, the graph is going to come down and touch the x-axis, but it is not going to cross. So you'll have kind of a minimum or maximum at the x-axis. So it'll just occur at one point. So we're going to say that that touches the x-axis. That is when our degree is even. okay? When the degree is odd, then the graph is actually going to cross through the x-axis. So kind of like a line would, where that is x to the first degree. It's going to cross right there. Okay, so it crosses the x-axis. Okay, so let's go ahead and do this first example. If we look at it, we have 2 times x minus 3 times x plus 2 squared times x minus 1 to the third. So the leading coefficient is the 2 here, okay, which is positive. The key takeaway from this lead coefficient is whether or not it's positive or negative, because that's what we're going to use to determine the end behavior. Then we look at the degree. Well, we have x minus 3 to the first, plus we have the 2, and we have the cube. So 1, the 2, and the 3, add those together, and we get a degree of 6, which is an even number. So the key element here, components of those, is that it's positive and it's even. What is wrong with me? Let's erase that. Put a V in there. Okay. And once we know that it's positive and even, we can then determine our end behavior. So it's going to be rising and rising. Anytime we have an even degree, they're going the same way. And anytime it's positive, they're both going up, rising, rising. And if it was negative, they'd be going down. But since it's positive and even, we're rising, rising. Okay, x-intercepts. That's going to be our zeros from each of the factor. So x equals 3, because 3 minus 3 is 0. X equals negative 2, because negative 2 plus 2 is 0. And x equals 1, because 1 minus 1 is 0. So those are our 3 x-intercepts. X equals 3, negative 2, and 1. All right, then we look at the degree of each 0 to determine if it is going to touch the x-axis or if it's going to cross the x-axis. So remember, even degree zeros are the ones that are going to touch. So that would be the second degree here is even. So that would be x equals negative 2. The others are odd. First degree and third degree, 1 and 3, both odd numbers. So x equals 3 from the first degree, and then x equals 1, that was third degree. Okay, let's go ahead and plot, oh, where's my graph? There it is, sorry. Okay, let's go ahead and plot those on the graph paper. I'm going to start out with my zeros. Negative 2, 1, and 3. So we know we're going to touch the negative 2, cross the 1, cross the 3, and our end behavior is going to be rising, rising. I'm going to go ahead and put my end behavior. I know it's going to be to the left of the negative 2, and I'm also going to be rising to the right of the 3. Okay. So I'm touching the negative 2, and I'm crossing the other 2 zeros. So I'm going to start drawing my graph. Come down, I touch, and I go back up. We do not know where the maximum is, but I do know I need to go back down and cross the 0 at 1, so I'm going to head back that way. I do a little U-turn wherever I want. This is just a rough sketch. Come down. Again, I need to do another U-turn to cross again at 3, and then go find my end behavior, and I'm done. Okay? We do not know exactly where those minimums and maximums occur during this class. Okay? That's a calculus skill. That's why in the directions are just simply to sketch a quick graph. Okay? So that is the notes for 7.5. Please let us know if you have any questions. We're happy to help. Have a good day.